chicka, bow, wow, bow, chicka, wow, wow.
Alright, this video isn't an instructional video, but we are going to take a look at a specific example when we looked at in class. This one is exploring angles in particular. So we're given a diagram on right, shows a bunch of lines intersecting. We're told that lines AF, HD, and GC all intersect at point P. It's consistent with our diagram. We're told that AF and BE are parallel. That's what these two lines mean. So I'm going to show that on my diagram with the arrows. I'm going to write that in. And I like doing that because when you show it on the diagram, then I don't need to go back and read everything again. I'm not going to forget it because I can see it in front of me. We're told that HPG is 70 degrees, and that's written here. We're told that PRE is 150 degrees. Again, that angle is shown here. And we're asked to find out what is this angle PQR up at the top. Now, whenever these types of situations, notice we're asked to justify our reasoning. We're going to set up a table. So on the left, I'm going to make a statement. Basically, the statements are a new angle that I know. So I'm going to calculate, say, well, this angle is this much. Well, that means that this new angle must be this amount. And then my justification, which is just, well, what is the mathematical principle that we have applied that allows us to draw that particular conclusion. And there's a lot of different ways you can go about this one. And I'm just going to look at one possible way that we can do it. I'm only going to do one, and then we can maybe look at a couple quick other ways. Now, what I like to do first is before I start really laying out all of my statements, I just want to go to the diagram and figure out, well, how am I going to do it? And I build off the information that you know. So I got the 70 and the 115. And again, there's multiple ways that you can do it. So sometimes it'll take a little bit of trial and error. So if I look at the 70, well, what else could I figure out? I could figure out this angle over here. But I'm going to say this angle in here must also be 70 degrees because these two angles will be vertically opposite. And as we've noticed in the past, vertically opposite angles are always congruent. Now, PQR forms a triangle, and we know that a triangle has 180 degrees. I currently have one angle. Well, if I could find this angle down here, then I could find the missing angle. And down here we notice that this angle here and this angle here, they both add up to 180 degrees. They form a semicircle or a straight line. And since this one's 115, then that means this angle here must be 65 degrees. Because 65 plus 115 is 180. And since I know these two angles now, we could figure out what this angle up here is. So let's lay it all out and then we'll do our calculations for up here. So the first thing we said was angle QPR. So I'm going to write that down. We said the angle QPR, again remember we put the vertex that occurs in the center, and we said that was equal to 70 degrees. I'm just going to write out degrees because saves a bit of time there. So QPR is 70 degrees. Now, how do we know that? Well, in my justification, I'm going to say how it's connected. So we says vertically opposite. And then I'm also going to say to which angle. So to angle HPG. And since vertically opposite angles are always congruent, since these two angles are vertically opposite, then of course they must be congruent. Now we can look down here at this 65. Well, where did that come from? Well, we said that these two angles were supplementary. That means they add up to 180 degrees because they make a straight line. So we took 180 degrees. So again, I'm just going to show it over here. The idea of a proof here, or justification, is we're going to spell it out. We're going to make it very obvious. So we're going to say angle PRB equals 180 degrees minus 115 degrees. The whole thing, because it's a straight line, must equal 180. Since there's 115 degrees over here, the rest of them must be on the other side, and that gives us 65. And again, I'm not going to bother writing out degrees here. We kind of know it's obvious. It's an angle. It's going to be in degrees. And then again, well, what was our justification? Well, we said it was supplementary to angle, and again, I'm going to give the name angle PRE. We could also say, supplement angles that form a straight line are supplementary. Most of what I use here is kind of abbreviations for longer statements that we've looked at in class. and going from there. All right, well, in our last statement here, this one's 70, this one's 65. We can figure out angle Q. So I'm going to say pardon me, I have to be more specific than just angle Q. It's over here. Angle PQR. PQR equals 180 degrees, because there's 180 degrees in a triangle, minus 70 degrees for angle QPD, minus 65 degrees for angle PRQ. And I'm just going to move it down here. And that equals 55 degrees. I think that's right. 45 degrees. 135, 180. So angle PQR equals 45 degrees. And how do we know that there's 180 degrees? Well, because we know that a triangle has 180 degrees. And all three of these angles obviously form a triangle. So we can go back up here, and I'll put it in green. This angle here is 45 degrees, which matches, I don't want to put all the degrees in, but matches what we had down here. So there we go.
You're still here? It's over. Go home. Go.